Chapter 8, Project. For this project, you have several choices of experiments that you can perform. You can measure the height in inches and the person's foot length in inches without shoes on for at least 15 people. And you'll want to do good sampling to get those 15 people. Record the ordered pairs in this form, foot length, comma, height. And you'll need to have a measuring tape of some sort to do this part. If you don't like that project, there are several others you can choose. Some of them don't have any humans involved, and so you don't have to worry as much about sampling. But here's when you measure the diameter and the circumference of empty cans or jar lids. And you'll record ordered pairs with diameter, comma, circumference of lid. And you need 15 sets of data. You'll need some cans and some lids, and you'll need some a tape measure. Another experiment is to count the number of dry beans that will fit in a jar lid without any overlapping. So you take your jar lid and put all the beans in and make sure they lay flat. And then that's like a way to measure the area of the jar lid. And you want to have an ordered pair that gives you the diameter of the lid, comma, the number of beans. And you'll do that for 15 different lids. You'll need some jar lids, some dry beans, and a ruler. Here's when you vary the length of a string and measure the period of a pendulum, and it explains more how to do that. If you're scientifically inclined, this might be something you enjoy doing because you count the number of swings of a pendulum, and it tells you exactly how to do it so that you don't have too small of a measurement area. Here's another one. If you liked our probability sections, you can roll 20 dice. So you have to have a lot of dice to do this. After each roll, remove all the dice that show a 6. And you keep doing that until all of the dice are gone. And what you want to do is record ordered pairs that say what roll number you're on and how many dice are remaining. So if you roll all 20 dice and you don't have any 6s, then you would have a 20 or number 1 for the number of rolls, and then 20 for the number of dice remaining. And then you roll again, and you'd have a number 2 for the rolls, and then however many dice are left because you take out the ones that came up with a 6. So you keep doing that until you're out of dice. That sounds like kind of fun if you liked our probability experiment. Students measure, this one sounds really interesting to me. Students measure the height of a car and the height of its tires. And then you record the ordered pairs, the height of the tire, comma, height of the car. You need at least 15 cars. You need a measuring device and a parking lot with a bunch of cars. Now for this, I recommend that you do systematic sampling. So you measure, like, you pick a number, like every 5th car, you'll measure the height of the tire and the height of the car. And so you only do the 5th car for every 5th car in the row until you get the number that you need, which is like 15. Okay, students record the number of square feet a house has and the number of windows a house has. You can ask all different people to give you information. Most people know how many square feet their house has, so you would just ask them that. How many square feet, how many windows? You need at least 15 houses. Now remember, this needs to be a random sample, so you need to think about ways to make sure that you choose a random sample, not just put a survey on Facebook. You can't take everybody's information. So you could do, let's see what would work. Here's the list of ways you can choose a random sample. So for each experiment you are going to conduct, make sure that you're thinking about, how can I make this a representative sample? So for example, the cars in the parking lot, you need to make sure you're using perhaps systematic sampling. You could do cluster sampling, random sampling. There's some ideas here, but make sure you're using one of these methods, and then you'll describe what you did in your report, like what method you used and how you made sure that your sample was representative. So make sure you do that. If you're just using lids for jars, why don't you take a bunch of lids, put them into maybe a grocery bag or something, shake them up, and choose 15, and that would make that a random sample. Okay, so then you'll want to make a table to collect your data. I used data for my example that was kangaroos, and it was the width of their nose and the length of their nose. And so what I did is, there we are. Here's my table of the data. I have the nasal length, which I was using as my X value, and the nasal width, which I used as my Y value. And so I put all my pairs, X and Y, each on its own row like this. And you should do that as well. And let's see, I lost my paper. Here we go. Okay, if you're surveying people about their houses, for example, or about their height and their foot length, then you don't need to report their names, but you do need to have their data in the XY form. And when you're collecting it, I recommend that you put a name on there so that you don't accidentally measure a person a couple of times. Yeah, but don't put them in your report, just the data that you collected from them. Then you go collect your data, whichever experiment you did. Oh, if you don't have the supplies and you can't figure out a way to improvise for the supplies that are listed in the one of these experiments, if you decide you want to do this experiment with the string and then you find out you don't have any way to make the string hold a weight, then you should pick a different experiment. That's as simple as that. Don't try to force an experiment into something completely different because you don't have all the parts. There's a lot of different experiments. You should be able to find one that'll work for you. You will need to calculate a 5-number summary for each of your variables, and I have an example video to show you how to do that. You can use Excel or Google Sheets to help you with this. I recommend Excel because it does the quartile 1 and 3 in the method that we have been using through this semester. And then you need to create a box plot for each of the 2 variables, and I have a video to show you how to do that. Here's an example of your the box plot grapher that I recommend that you use. It's very nice. This is the best thing I've seen so far. And then you need to create a scatter plot that shows your regression equation and an R-squared value from your collected data. You can use Google Sheets or Excel. I have a video showing you how to do it in Excel and how to go from the R-squared value to an R value. So you need to do that as well. Using your calculator, or you can use Excel, it's fine. Find the R by taking the square root of the R-squared that we get from this scatter plot. And then this is something you'll have to do like we've done for homework. Determine if the R is statistically significant. Use your sample size, so it's probably about 15 or so, and a 0.05 significance level. And so you'll talk about what your results are with that significance test. And then use some personal data. So if you collected shoe size or foot size and height, then you would look at your foot size and predict, using the equation, predict the height of you, and then you can compare it to your actual height. If you are, if you did an experiment like the number of beans that fit into a jar lid, then you would want to pick another jar lid that wasn't in your sample and do the measurement on its diameter and use that to predict how many beans would fit in the lid. Okay, and so you're going to find your Y hat based on the X value. So either your personal X or a new experiment, just find the X for whatever your experiment was and use the formula to predict your Y hat. And then you want to, number 11, generalize based on your linear regression equation and your R value, whether or not the 2 variables that you chose are correlated. So we want to look at, are they correlated, and state your level of significance in your conclusion. And remember up here we said use a 0.05 significance level. So you want to state it again down here, whether the 2 variables are correlated and how certain you are. And then finish up your report. explain the project that you chose, explain your decisions for each of the steps above and the results, and then make a conclusion.